In this session, we will learn about inserting PLC modules through a different way. See, I'm just going to uh, in icon menu. There you can see the PLC IO option here. Here again PLC IO modules. So here you can see the different makes like ABB and Allen Bradley are the two manufacturers which is available in my library at present. Once you click this plus, you can see many others falling under this Allen Bradley brand name. These are all different series of IO cards. There are different series. So, for example, if I want to use 1794, which many industries commonly use this series 1794 Flux IO. If I click here, under this there are many options like analog combination, analog input, analog output, and many. So even under this, for example, if I go to discrete inputs, again there you can see many others. They actually they are different in the number of channels and even the input supply voltage of these particular modules. Few are of this, for example, IB16, which is operable in 24 volt DC supply, and IA16, which is 110 volt AC supply, like that. And 16 is basically 16 channel. You can connect 16 inputs to this particular module, and for IA8 there are only 8 channels, and many options are there. Now, for example, let me put 1794 IB16 here. Again here, this graphic styles, many styles. You can use whatever you want. I prefer to go with style 1, and once I click IB16, it comes here. You see here, the description you can see. It have 16-point sinking input. TB3 is the terminal base of this particular module, and the rating is of 24 volt DC. Okay, I'm going to insert this module right here in my drawing. The spacing between IO points. We know 16 IB16 has 16 inputs. So what should be the spacing between each IO point or each terminal blocks? So let me put 0.75 for example. Okay, again, if you want to add spaces or breaks, now for this particular instance I don't want any breaker. I'm just going to insert it. Okay, now the module number, let us say this is my first module. Okay, or A1, let us say A1, this is my module 9, and here you can select the IO description format, the IO address format. I stands for input, A1 is my module number, and the IO address, whether it should start from 00 in this format, there are many formats. Okay, so I will choose this one now. Okay, so it will ask you whether you want to break it after inserting few terminals. If you want to break it, you can choose yes, break now, otherwise no. But for this case, I am not choosing no, I don't want to break it. Okay, so now my module is inserted into the drawing. AB is the make, Allen Bradley 1794 series, module A1. You remember we have provided module name A1, Flux IO, 24 volt DC. These are the descriptions which is already inside your database, and these are the terminals. Okay, this is how we can insert a PLC IO through icon menu. Now, if you closely watch this, suppose you want to connect wires to these terminals, all these input terminals, starting from IN0, 0. IN means input. 0 to, you will see till 15 here. 15. Input 15. 0 to 15. That is, there are total 16 inputs we can connect to this particular module. If you want to connect wires to this particular terminals or 16 TB terminal points, what you can do is, one way is you can add wires one by one like this. You can add wires, but this is time consuming, right? So another option which you should use is go to multiple bus, select component here. Okay, now you can see a green cross comes across in all these terminals. If I zoom in, it will disappear. It will disappear now. Now again, if I show you component, you see the green cross comes in all terminals. You note that this cross is on the left side of all these terminals, which is in the left side of the module. The cross is on the left side of this terminal, but you see B16, it is there on the right side. That is basically the connection point of those particular TVs. Now if I want to connect the wires into these TVs, what I have to do is, I will show you again. Go to multiple bus, select the first option, which is component. Okay, just make a cross like this for the 16 points, enter, and move your mouse towards left direction. Here it is drawn, all the 16 inputs. You can save a lot of time, and you see the connection point here. It is connected in the left side, which was there. Here you see this green cross. That is basically the connection point. That is basically the connection point. Even if I draw a wire like this, from here if I draw a wire, it will get trim here, trim here. Okay, in this way. And if I want to add a 24 volt supply, 24 volt DC plus, here I can connect it like this, and here this is the negative point. I will connect it like this. But in fact, I should trim this particular wire, and I will draw a similar wire like other 15 inputs. So this is how I can draw wires to a PLC IO module. There are two ways. Basically, the standard way of drawing wires in an input module is the wire should start from left to right. I mean, the module should be placed in the right side, and the flow of wire should be from left to the module. And if I try to draw, I'm just deleting all these wires. If I try to draw in the opposite direction, what will happen? Let us see. I'm making it a window like this, enter. I am moving it in the opposite direction for this input modules. See, I am unable to draw any wires. I can't draw any wires towards the right direction for an input module. So for an input module, you should always draw wires to the left hand side. In this way, you can draw. But for an output, let us see how it works. Again, go to PLC IO, PLC IO here. Now this time I am going to select, this is discrete input. I am going to select an output module, OB16. Okay, OB16, okay. I am going to place it here. Spacing, same spacing I am going to provide for this two. Okay, okay. Module, let us say B, this one. This is my output, so I will choose O. as a prefix. Okay, no, I don't want to break it. Continue, no break. It's done. It's output module. Allen Bradley 1794 OB16 module B Flux IO 24 volt DC. The descriptions comes here. Okay. Now you see the difference. In the input module is you can see the 16 TBs on the left hand side of this module. For an output you can see it on the right hand side. So that means you can draw wires in this. Again you see the green cross comes across all the TBs. Enter, bring it to its right. This way. This way you can draw the wires. In fact, this one is not an output. Output is starting from out 0 to out 15. These are the 16 outputs. Here in the top you may have to give a 24 volt DC plus supply here and minus here. From an external source you have to give a supply here. This is how it works. And for an output module, if you try to draw wire from right to left, from left to right, what will happen? I'm selecting this and now I'm trying to draw the wires towards left. Again the same thing, I cannot draw. So for an output module you should always, you can see, note this from this green mark. From this green mark you can note. I will zoom it a little bit more. See this green mark, that is the connection point. So you should draw wire from that end only, not from the opposite side. Fine. So draw wires, enter, this way. This way you can draw wires. This is how you can insert different types of module and you can add wires within seconds. No need to draw individual wires. And if you want to increase the spacing, you can of course do the spacing elsewhere. For example, if I am going to PLC IO module 7 OB16, I am going to insert it now. See here, I am inserting the same thing here with the spacing 1. You remember earlier we provided 0.75 as spacing. 1, 1, okay. Modulator side is C, okay. Output C, okay. No break. Now you see the size. Modules are same. Both the modules are same only, but the distance between these 2 points, these 2 pins, first one this and second one this. This is now 1 mm and in this case it is 0.75 mm. If you measure the distance, you will see from here to here it is, see, 0.75 here in this command line, 0.75. But here if you measure it, it will be 1. So this is how you can space the distance between IO points. And sometimes what happens is, in one sheet you may need to break these modules, because like this, for example, in this input modules I may require to show some field connections. Basically these wires can be come within the panel or can be coming externally coming from the field. So sometimes some customers may ask you to few details in the field. Before going to field, I will show you one more thing. If I want to insert a push button, how I will do? I want to insert a push button in this 7PB3 it is asking. In fact, there were few I have inserted previously, those blocks are lying somewhere in this drawing. That is why it is starting from 7PB3. I have given it is 7PB1. Okay, I am not going to give any descriptions here. One option is, okay, repeat, use 7PB1 Just a minute, I will just purge this drawing. Some blocks are lying. Now you can see push button. Here now I'm going to insert here. Again 7pb1 should be there. I don't know why it is coming. Okay, maybe in some other sheets it is given. That's why. Anyway, I'm just to override 7pb1, 7pb2. It should be my number. Okay, repeat. Yes, duplicate. Now 7pb3. Okay, repeat. 4. Okay, repeat. This is one way of inserting components. You can insert push button NO, NC, anything like this. Now I will insert a NC push button, mushroom head NC push button here. 7pb5. Okay. Now if I want to insert a similar push button in all, I don't need to insert again and again. There is a pick master here. Multiple insert pick master. Just select this, make a fence like this. Keeping the ortho one will be a better option. Okay. So keep all, don't ask. These options you have to just practice. There are many options, many combinations. It is not possible to demonstrate all through a tutorial. In fact, you have to practice with all options. I will show you two. Here you see I'm keeping all, don't ask. Show edit dialog box. Now I am just switching off those option, that option. I am just inserting. See, you see, it has inserted all the components in this way without asking anything. Now I'm just inserting another component like luminous push button in series with this. For example, here I am putting LPBT1. Okay. Using pick master, now I am going to insert multiple components like this. Keep all. Now I am not going to switch off this thing. Show edit dialog after each. If I do this, earlier case I turned it off. Now I am keeping it on. Okay. Now what happens is after inserting one push element, it will ask you to give some feeder inputs like description. If you want to add some description like reset. Okay. Now next again it will insert one and ask you to give description. Let us say lamb test. Okay. Again it will ask you to put some description, test. Okay. And so on, so on, so on. You have to give the description. You can change anything. I mean, this is an option. In the first case, it was not there because what we have done is multiple insert. We have taken. We switched off this show edit dialog box. We don't want to see the dialog box after inserting each component. So just keep it off. So that's why you can avoid it, and that by keeping it on you can provide more information after inserting each component. This is one way of doing this thing. Now every module should have some description along with this IO point. Like for input 1, what is this input 1 stands for? So we can in fact add description to these modules. How we can do that? Go to edit, select this component. See here you see this I stands for input, A1 that is our module name, 00 is the channel. Here I can provide descriptions like for example motor number 1 start. That is the description which I am going to give for my first input, that is 00. Now go to 1, that is motor number 2. Motor number 2 start. Okay. Now coming back to the, see, in this way you can do. And in fact if you want to copy, just click. If you want to copy one of this, see here I have selected the third channel. 02 is the third channel, and I want to add something, copy from here. I'm just click here, confirmation, description 1, 2, 3, copy this description IO point. Okay, you can copy this here, and motor 1, say forward start. Now you see, motor 1 is the start, 2 is start. I have copied the third option. Now my first one is motor 1 start, second is 2 start, third is 4, 3 is blank now. For 3, if I want to copy this one, I can copy here, okay. Instead of forward, I can put reverse. That will come in my fourth channel, that is 03. In this way, you can add description to the modules. This is another part. Now, sometimes, as I said, we may require to show more details here. There may be few push buttons coming in parallel, and few switches and few external supplies coming to the push button, and finally which is going to this module. So we may not get sufficient space here to show all the details, because the spacing is too small. 0.75 or even 1 will not be sufficient enough for you to show the details in depth. So what you can do in those cases is, I will just simply move this the component, move circuit. I will simply move this. I will keep it here. Now I will insert a module, icon menu, Plc Io, Plc Io modules. Now let us say I am going to insert a 32. Now let us insert a 32 channel module, 1794 32 channel. OB I don't see it here, 1794. I will go here, 1756 digital discrete input, here IA32. Okay, this is 32 channel module. I'm going to insert it here. Too big, right? Now let me say I'm going to provide one space, insert all, okay, 1, okay, rack number is D, slot is 0, okay, let us choose this one, okay, no break. So it will overflow your drawing title block template. So we don't want that to happen. So in that case, what we can do is, we can insert this module, adding few breaks, allows spaces and breaks, okay. So D, slot 0, 1, this is okay. Now you see, insert next IO point, insert next IO point, next IO point, next IO point. In this way I can put, if I want to add some extra space now before inserting the next IO point, I can add some space. You can see the red cross come here. I can add some space. Now I can again insert a component, again insert IO point, again insert. Now again I want space. Insert IO point. Now I want to break the module. Break now. Now it is braked. The other portion I am going to insert here. Okay. You can again insert IO point like this. Continue no break. Made break module now. Again, if you want, you can break. Otherwise, you can insert insert, 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 insert. In this way. Now, the basic concept is that if you want to add some extra few things in between these mode IO points, you have the option to give extra space, and in fact you can break the module into many parts. So even in one sheet, just deleting this, if you want to show all the modules in one sheet, you can break it into one or two or three pieces. You can place it here and you can show the details in a tidy way. So that option is also here. Okay, so that is all about this session. And before wrapping up this session, I will just tell you one more thing about inserting few TBs. Now let us assume there are few wires, and if I want to insert some terminals, I will see here. Here it is, terminals and connectors. Here I am going to put a terminal here, like one, this one. TB strip I am going to 71 1. Okay, I have inserted a TB here. Using Pickmaster, I can insert many TBs. Keep all. It will keep on increasing the number. For example, now if you want to delete a few TBs in between, now you see the number 6, then comes 9, 7 and 8 we have deleted. So there is a option, the components, terminals, terminal strip utilities, pick mode, renumber pick mode. Here it is 6 and start there, then it starts with 9. In fact, it should start with 7. So type 7. You see the command line here, start with 7. Okay, just pick one by one. 8, 9, 10. And many times it may require. Sometimes what happens is the external TBs will be given for cables coming from the field, and in 1794 IO modules you can directly connect the wires to the TB3 base. 1794 modules, that option is there. There you may not require these extra TBs, but sometimes you may require as per the customer requirement, and in those cases some may require TBs, some may not be required TBs. So during those applications you can utilize this functionality, terminal strip utilities, and renumber pick mode. Terminal renumber this project weight, that is also there, that we will touch later on. This is all about in this session. Thank you, and next session we will come with something